when light refused to obey common sense. For centuries, light seemed simple, obedient, and well understood, a smooth wave spreading endlessly through space without resistance or hesitation. It illuminated worlds, warmed planets, and carried information so reliably that no one thought to question its loyalty to intuition. And then, without warning, light stopped behaving the way it was supposed to. To understand why this moment mattered so deeply, we must return to a time when physics felt unified and confident. Light was a wave, just like sound in air or ripples on water. It bent, interfered, reflected, and refracted exactly as equations predicted. Experiments confirmed the math repeatedly. Confidence hardened into certainty. This certainty shaped technology, and theory alike. Optics advanced. Telescopes improved. Electromagnetism unified electricity, magnetism, and light into a single elegant framework. It felt complete. There was no hint that something fundamental was missing. Light appeared loyal to the rules. Then physicists began studying how light interacts with matter more closely. When light struck metal surfaces, electrons were ejected. At first, this seemed straightforward. Brighter light should knock electrons out more forcefully. More energy meant stronger effect. That was common sense. But the results refused to cooperate. Increasing brightness did not increase electron energy. Changing color did. Below a certain frequency, no electrons were released at all. No matter how intense the light became, nothing happened. Light was ignoring effort and responding only to color. This behavior shattered intuition. If light were a wave, energy should accumulate smoothly. More brightness should eventually overpower resistance. But light behaved as if it arrived in indivisible packets. Each packet either had enough energy or it did nothing at all. There was no compromise. This was not a small discrepancy. It was a direct contradiction of classical theory. Light was acting like a particle. Not sometimes, not approximately, but decisively. Physicists resisted the implication. They blamed experimental flaws, surface impurities, measurement error, anything but the idea that light itself had changed identity. Yet repetition only strengthened the result. Light refused to obey expectation. When explanation finally came, it was unsettling. Light carried energy in discrete chunks. Photons, each with fixed amount determined solely by frequency. Brightness changed quantity, not strength. Reality had quietly enforced limits no one had imagined. This moment marked a turning point. Light was no longer a wave alone. It was also a particle. And worse, it was neither fully. It occupied a category intuition could not grasp. What seemed like a technical anomaly became a philosophical rupture. If light could ignore common sense, then reality itself was not obligated to feel intuitive. And physics was about to discover that understanding the universe would require abandoning comfort entirely. Once light revealed this strange dual nature, the foundations of physics began to tremble in unexpected ways. Waves were supposed to spread smoothly, sharing energy continuously across space. Particles were supposed to be localized, delivering energy in discrete impacts. Light was doing both, depending on how it was tested. And worse, it refused to explain itself. At first, physicists tried to keep the old picture intact. They treated photons as a convenient accounting trick, a mathematical shortcut, something temporary that would eventually disappear once deeper equations were found. But experiment after experiment closed every escape route. Light behaved like a wave when traveling. It behaved like a particle when interacting. And no single classical model could contain both behaviors at once. This contradiction became impossible to ignore. If light could switch identities, then the problem was not light. The problem was intuition. Reality was not obligated to choose a single category. It was free to operate in ways human language could not comfortably describe. As research expanded, the same pattern appeared elsewhere. Electrons diffracted like waves. Atoms interfered with themselves. Even large molecules showed wave-like behavior under the right conditions. The boundary between particle and wave dissolved completely. Nature refused to label its creations. The universe was not built from objects moving along clear paths. It was built from probabilities, from likelihoods, from mathematical descriptions that predicted outcomes, not stories. Between emission and detection, light did not travel as a tiny bullet. It existed as a spread of possibility. Only interaction forced a decision. This deeply unsettled the idea of realism. If light did not have a definite state before measurement, then observation was no longer passive. Measurement did not reveal reality. It helped create it. The act of detection mattered. This meant the universe behaved differently depending on how questions were asked. Set up an experiment to measure waves, and light behaved like one. Set it up to detect particles, and particles appeared. Reality adapted to the question, not because it was conscious, but because its rules were conditional. The double-slit experiment made this impossible to dismiss. Light passed through two openings and interfered with itself. Not sometimes, always, until detectors were placed. Then the interference vanished. Behavior changed instantly. Nothing about the light source changed, only the act of measurement. This shattered the final hope of classical explanation. Light was not hiding a simpler truth. It was expressing a deeper one. Reality did not exist in a single, well-defined state at all times. It existed as a range of possibilities, collapsing only when interaction demanded an outcome. The refusal of light to obey common sense was not rebellion. It was revelation. The universe was not broken. Human expectation was. And physics had crossed a line beyond which certainty would never fully return. This is where the true conflict emerged, not in equations, but in meaning. If light did not possess a definite state before measurement, then reality itself was incomplete until interaction occurred. The universe was no longer a finished script unfolding deterministically. It became a system that waited, a system that offered possibilities instead of certainties. And that idea was deeply unsettling. Classical physics assumed the world existed independently of observation. Stars burned whether or not anyone looked. Light traveled whether or not it was measured. But quantum behavior shattered that assumption. Light behaved as if it did not decide what it was until the moment it was forced to respond. Before that moment, it existed as overlapping potential, not as a single story. This raised a dangerous question. What exactly collapses when measurement happens? Is it the wave, the particle, the information, or the description itself? Physics could predict outcomes perfectly, yet could not describe what reality was doing in between. The universe answered questions, but refused to explain its internal process. Attempts to restore certainty multiplied. Hidden variables were proposed, undetected mechanisms, deeper layers beneath quantum behavior. But every experiment designed to reveal them failed. Bell's inequalities closed the door. No local hidden explanation survived. Nature was not secretly classical. Even worse, the randomness was not noise. It was structured. The probabilities followed exact mathematical rules. Outcomes were unpredictable individually, yet perfectly predictable in aggregate. Order existed without determinism, control without certainty. Light became the symbol of this shift. It showed that nature does not commit early. It delays decisions. It allows incompatible possibilities to coexist. Only interaction forces resolution. Reality is economical with commitment. This destroyed the idea of an objective narrative. There was no single path light traveled, no secret trajectory waiting to be discovered, only a spread of allowed outcomes, each weighted by probability. Reality was not a line, it was a cloud, and yet this strange behavior was not fragile. It was universal. Every photon obeyed it. Every experiment confirmed it. The universe was built this way, not broken into it. This forced physics to change its goal. Instead of asking what is happening, it asked what can happen, and with what likelihood. Prediction replaced description. Statistics replaced certainty. And understanding became conditional. Light did not just refuse common sense. It dismantled it. It showed that intuition evolved for survival, not truth, that reality operates on rules, far stranger than experience prepares us for. And once this was accepted, a final implication surfaced quietly. If observation shapes outcome, then the observer can never be fully removed. And physics was no longer studying a detached universe. It was studying a relationship between reality and interaction itself. The climax of the story was not a single experiment, but a reluctant surrender, Physics finally accepted that light was never meant to feel intuitive. It was not broken. It was honest. And honesty came at the cost of certainty. Once wave-particle duality was accepted, the universe changed character completely. Reality was no longer composed of things with fixed properties. It was composed of probabilities waiting to be resolved. Light did not travel as a particle. It did not spread only as a wave. It existed as potential, shaped by rules, until interaction demanded an outcome. This realization reshaped every corner of modern physics. Electronics rely on quantum behavior. Lasers function because electrons jump discretely. Solar panels work because photons deliver a fixed packet of energy. The modern world exists because light refused to obey common sense. Technology is built on that refusal, yet the strangeness never disappears. No matter how familiar the equations become, the meaning remains unsettling. Reality does not exist independently of interaction. Measurement is not passive. Observation is participation. The universe responds to how it is questioned. This does not mean reality depends on human consciousness. It means interaction matters. Detectors, screens, atoms, anything capable of exchanging information. The universe defines outcomes only when forced to do so. Until then, it remains open. Light taught physics a final lesson. Nature does not prioritize clarity. It prioritizes consistency. The rules work perfectly, even when meaning feels incomplete. The universe functions without explaining itself. What once felt like a flaw became a feature. Uncertainty allowed stability. Probability allowed structure. Quantum rules prevented collapse. Light's refusal to behave classically made matter possible at all. This moment did not weaken science. It strengthened it by teaching humility, by setting limits, by revealing that understanding does not always mean visualization. Sometimes it means acceptance. Light did not betray physics. It exposed its assumptions, and in doing so, it opened the door to the deepest understanding reality has ever offered. Sometimes the smallest shift in perspective becomes the beginning of a new future. When light